Stop chasing fragile selectors, turn a permitted web page into validated JSON with a browser, AI, and Pydantic. Let's begin with the result we are building. This scraper turns a permitted web page into clean, validated JSON instead of a pile of machine learning. Our demo reads a quote page and returns the quote text, author, tags, and source URL. The browser layer renders JavaScript, the extraction layer maps meaning into fields, and Pydantic rejects malformed results. Changing the output means changing a data model and extraction instruction, not rewriting every DOM traversal. That makes the workflow useful for product feeds, job listings, articles, and research ingestion. But any website is not literal. Logins, captchas, access rules, and unusual layouts still require deliberate handling. By the end, you will have a reusable pipeline and know exactly where AI helps, and where it does not. By the end, you will have a reusable pipeline and know exactly where AI helps, and where it does not. That sets up why traditional scrapers break. A traditional scraper often depends on a chain such as div_card_span.price. Rename one class, wrap the price in another element, or render it later with JavaScript, and the selector can return nothing. Selenium or Playwright solves browser rendering, but it does not decide which text represents the product name or price. An LLM can interpret cleaned page content semantically and map it into a requested schema. That reduces dependence on exact nesting when several sites express the same business fields differently. It does not remove maintenance, page meaning can change, fields can disappear, and models can invent values. The stronger pattern is browser retrieval plus semantic extraction plus deterministic validation. With why traditional scrapers break in mind, the next piece is the four-layer architecture. The input layer accepts one approved HTTP or HTTPS URL and blocks unsupported schemes or unapproved domains. Crawl4AI controls a Playwright browser, waits for the page, and converts noisy machine learning into cleaner content. The extraction strategy asks an LLM for objects that match our Pydantic JSON schema. Pydantic validates types and required fields before anything is written to disk. A result envelope also records the source URL, extraction time, item count, and errors. If any layer fails, the pipeline stops with a visible reason instead of saving plausible-looking bad data. This separation lets you replace the browser, model, or output destination without rewriting the whole system. That idea leads directly to permission before automation. We will use quotes.toscrape.com, a sandbox created for scraping practice. On a real project, first check the site's terms, applicable law, copyright, and whether you have permission to collect and reuse the data. Read robots.txt for crawler preferences, but remember that robots' rules are not access authorization. Never bypass authentication, captchas, paywalls, rate limits, or technical restrictions without explicit authority. Collect only fields needed for the stated purpose, especially when personal data may appear. Use a truthful user agent, conservative request rate, caching, and a clear contact path for sustained crawling. Ethical collection is part of the architecture, not a disclaimer added after deployment. Once permission before automation is clear, project setup becomes much easier to understand. Create a fresh Python 3.11 or 3.12 virtual environment so crawler dependencies stay isolated. Install Crawl4AI, Pydantic, and Python.env. Run Crawl4AI setup to install the browser dependencies Crawl4AI needs. Use Crawl4AI Doctor if setup reports a missing browser or operating system package. Our folder contains the scraper, schema models, environment file, output folder, and tests. Keep provider keys in .env, never inside the Python file or a screenshot. A successful setup ends with the Doctor check, not with assuming pip install was enough. From there, the next practical step is define the JSON contract first. Before crawling, define what a valid quote object means. Quote item requires non-empty text and author strings, plus a list of tags. Quote batch wraps the list so the LLM and validator share one clear top-level shape. Pydantic can convert these classes into JSON schema for the extraction strategy. The same classes validate the return JSON before it enters another system. If a price should be numeric or a date should follow a format, encode that rule here instead of trusting the prompt. Schema-first design turns extract the useful parts into a testable data contract. This sets up the next important point, crawl the rendered page. Async web crawler launches the browser once and closes it cleanly through an async context manager. Browser config keeps Chromium headless for normal runs, switch it off temporarily when debugging page behavior. Crawler run config controls the individual crawl, including cache behavior and the extraction strategy we add next. The URL is passed as data to a room, and the returned object tells us whether the crawl succeeded. Crawl for AI can expose raw H machine learning, cleaned H machine learning, markdown, links, media, and extracted content. For AI extraction, cleaner content matters because menus, scripts, and repeated Chrome waste context and confuse fields. First prove that crawling succeeds, then add intelligence. First prove that crawling succeeds, then add intelligence. That sets up add semantic extraction. LLM extraction strategy receives 3 key inputs: model configuration, JSON schema, and a precise instruction. The instruction says to extract only visible quote cards and never indent missing values. The schema comes from quote batch.modelJSON schema, so the model sees the same contract Pydantic will enforce. We send cleaned markdown rather than the entire raw page to reduce noise and token usage. Temperature stays at 0 because extraction rewards consistency, not creativity. The model returns JSON text inside result.extracted_content. It is still untrusted at this point. AI handles semantic mapping, while code retains responsibility for success checks and validation. With add semantic extraction in mind, the next piece is scene 9, validate and save clean JSON. Parse the extraction response and validate it with quote batch.modelValidation. If a required field is absent or the response is not valid JSON, Pydantic raises a clear validation error. A successful batch is placed inside a result envelope with the source URL and item count. ModelDumpJSON, indent equals 2, creates readable JSON without hand-building dictionaries. Write to a known output directory using UTF-8 and preserve non-English characters. The success condition is not the script ran, it is the file contains validated objects and the expected count. Open the JSON file and inspect 2 records before trusting a large run. That idea leads directly to run the complete scraper. Put the allowed sandbox URL in .env, add your chosen model provider key, and run python scraper.py. The browser fetches the page, Crawl for AI prepares the content, the model extracts quote objects, and Pydantic verifies them. The terminal prints the output path and number of validated records. The first JSON object should contain text, author, tags, and the page source. Compare that object with the visible card in the browser to confirm field accuracy. Repeat the run once to check consistency. Extraction pipelines need repeatable output, not one impressive demo. We now have a working AI data ingestion step, not merely a page summarizer. Once run the complete scraper is clear, make dynamic pages reliable becomes much easier to understand. Modern pages may render an empty shell first and load cards a moment later. A fixed sleep is fragile because it waits too long on fast pages and not long enough on slow ones. Prefer a meaningful condition such as waiting for the quote card selector or a known result container. For load more buttons or infinite scrolling, perform one bounded interaction, then confirm the item count changed. Set a page timeout and maximum page count so a broken site cannot hold the crawler forever. Capture a screenshot or cleaned content sample when extraction returns 0 items, evidence speeds debugging. Reliable crawling waits for the data state you need, not an arbitrary number of seconds. From there, the next practical step is add guardrails and tests. Restrict outbound targets to an allow list or explicit project scope to reduce server-side request forgery risk. Resolve redirects and reject private, loopback, link local, or metadata service addresses before the browser follows them. Rate limit by domain, cache successful pages, cap response size, and stop after a bounded number of URLs. Test Pydantic validation with known good and deliberately broken JSON. Save a small approved H machine learning fixture so extraction changes can be compared without repeatedly hitting the live site. Track missing field rate, duplicate rate, validation failures, latency, and model cost per page. A production scraper needs quality gates and network controls, not only better prompts. This sets up the next important point: CSS first, AI when meaning varies. AI extraction is flexible, but it is slower, less deterministic, and usually more expensive than CSS or XPath. For one stable site with repeated cards, JSON CSS extraction strategy is often the better production choice. Use AI when layouts vary across sources or when the field depends on meaning rather than a fixed element. A strong hybrid learns or proposes a schema, runs deterministic extraction at scale, and sends failures to an AI fallback. Keep Pydantic validation after both paths so downstream systems receive one contract. Measure extraction accuracy on labeled pages before choosing the smarter route. The best architecture uses the least complex method that reliably produces the required data. The best architecture uses the least complex method that reliably produces the required data. That sets up adapt the pipeline to new data. To extract products, replace quote item with fields such as name, price, currency, availability, and product URL. For jobs, use title, company, location, employment type, posting date, and application URL. For articles, capture headline, author, publication date, canonical URL, and a short factual summary. Update the extraction instruction to define each field and what to do when it is missing. Add representative pages from every target layout to the evaluation set. Keep site-specific crawl rules separate from the shared output model so one change does not break every source. A reusable scraper is a configurable pipeline, not one prompt that claims universal understanding. With adapt the pipeline to new data in mind, the next piece is from page to trusted dataset. The finished pipeline validates the URL, renders the page, cleans the content, extracts meaning, validates JSON, and saves evidence. Crawl for AI and Playwright solve browser retrieval. The LLM maps content into fields, Pydantic enforces the contract. Permission checks, rate limits, network restrictions, and quality metrics make the workflow responsible and operable. Start with the scraping sandbox, then add 1 permitted site and 10 labeled test pages. Compare CSS extraction with AI extraction before scaling cost or complexity. The next useful improvement is a queue that crawls approved URLs, deduplicates records, and writes validated results to a database. Clean JSON is valuable only when you can explain where it came from and why it passed. To wrap up, here is the key takeaway. You now have a structured overview of build an AI web scraper that extracts websites into clean JSON. Review the core ideas, connect them to examples, and revisit concepts like the result we are building, why traditional scrapers break, the 4-layer architecture when practicing. Subscribe to Easy Machine Learning Guide if you want to learn AI through simple explanations and real industry examples.